Hi Geometry, we are doing 12.2 arcs and chords and we're going to learn about properties of arcs and chords. Our vocab is central angle, arc, minor arc, major arc, semicircle, adjacent arcs, and congruent arcs. So a central angle, if I draw a circle, that's kind of a circle. A central angle, as you may know, is anything where the vertex is on the center of the circle. Okay, so this would be a central angle. And arc then would be right here. It's an unbroken part of the circle consisting of 2 points called the endpoints, right here, and all the points in the circle in between them. A minor arc is an arc whose points are on or in the interior of a central angle. Minor arc. A major arc is an arc whose points are on or in the exterior of a central angle. So outside here is a major arc. So a minor arc, you only need 2 points to name it, like arc, measure of arc AC is x degrees. But a major arc, you have to have 3. So this would be measure of arc ADC is 360 minus x. So you can kind of see that that's the symbol for it when you have arc AC. It's kind of like that. And then, of course, we have semicircle. If the endpoints of an arc lie on a diameter, then the arc is a semicircle. So in this case, measure of arc EFG is 180 degrees. And I guess I just mentioned this, but minor arcs may be named by 2 points. Major arcs and semicircles must be named by 3 points. All right, on this problem, it says the circle graph shows the types of grass planted in the yards of one neighborhood. Find measure of arc KLF. Okay, KLF. That's this major arc here, right along there. So it's 65% of 360 degrees. 360 degrees because a circle is 360 degrees and this major arc is 65%. So when I multiply those together, I should get 234 degrees. This is the same measure as the angle. 234 degrees is the angle and the arc is 234 degrees. Let's try some other ones here. The measure of angle FMC. So FMC would be FMC. So we'd have this part and this part and this part. So we have 9%, 10%, and 11%. Well, I add those together, I get 30%. So I just need 30% of 360. And I get 108. So it's 108 degrees. And then the arc, measure of arc AHB, okay, AHB, that is this major arc 3/4 of the way, yeah, 3/4 of the way around the circle. So 75% of 360, you should probably have a good idea that that's 270 degrees. So that's the measure of arc AHB. Adjacent arcs are arcs of the same circle that intersect at exactly one point. So for instance, RS and ST are adjacent arcs. They touch. The measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. This is why I just threw on there because it's supposed to be on there, but it makes sense, right? AC is the same thing as AB plus BC. You will notice that these all have the wrong chapter. It should be 12-2-1. I changed it kind of on your notes. Not a big deal. Just know it's chapter 12. The rest of the part is correct. Just that 11 should be a 12. So let's find some arcs. So the measure of arc BD. So that's from here to here. Okay? Well, we need to know what this degree is and this degree. Please remember that vertical angles are congruent. So that means that 97.4 is the same as 97.4. And this is the same as this part here. So we have 97.4 degrees from B to C. But then how are we going to know what C to D is? Well, we know B to E is 180 degrees. So if we take 180 and we subtract that 97.4, and then we subtract the 52, okay, that's a rotten 2. Then you're going to get this measure of the CD part in here. I believe that equals 30.6. So then I just need to add, I have my BC of 97.4 and my CD arc is 30.6, and I'm just going to add those together and I get the answer 128 degrees. Here we have two problems. Find measure of arc JKL. So JKL, this part right here. Well, this is pretty easy because we have a half circle right here. So 180 minus 40 is just 140. And that's your answer for measure of angle, or I mean arc JKL. So this is 140 degrees. And LJN, that's going to go all the way around here. So that's going to be everything except for these two parts here. And this is 25 and this is 40. So I'm just going to take 360 and I'm going to subtract 40 and subtract 25. And it looks like I would get 295 degrees. Within a circle or congruent circles, congruent arcs are two arcs that have the same measure. Okay, makes sense. So here's a few theorems. In a circle or congruent circles, congruent central angles have congruent chords. Okay? If you have two of the same central angles, same measure, your chords are going to be the same length. Congruent chords have congruent arcs. So these little chords that are congruent mean that the arcs have the same measure. And congruent arcs have congruent central angles. So all three of these are pretty much interchangeable. If you have two central angles that are the same, then their chords are the same, then their arcs are the same. This says to find the measure of arc WS. Well, in order to do that, we have to know that these two chords are equal, and so therefore their arcs are equal. So let's set it up. 9n minus 11 equals 7n plus 11. I'm going to subtract 7n and add 11. So I got 2n equals 22, n equals 11, and then I just need to plug it back in, and I get 88 degrees. Here's another one. These have the same measure of central angles, therefore their chords are the same length. So 4t minus 26 equals 5t plus 1. So I got 9t equals 27, t equals 3, and I'm going to plug that in and I get 16. One more down here. This one says that the ray PT bisects angle RPS, and then we're supposed to find what length RT is. Well, RT is 6x and ST is 20 minus 4x. So we're just going to set those equal to each other. One more time. Add 4x. X is 2. And then I'm just going to plug that in and I get 12. Here is a few more theorems. In a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. Also, in a circle, the perpendicular bisector of a chord is a radius. Now, this is probably the trickiest part about this lesson, and not because it's difficult to do or understand, but because it's easy to forget how to do it. So these are easy to forget theorems. Let's take a look at this one, where we need to find NP. Well, as we know, this is a right angle here, which means that we have a bisector, meaning this length is equal to this length, okay? So what we can do is we can draw ourselves a little right triangle right here. Because we know this length here, because this is a radius, and we already know this radius. This radius is 17, so this radius is 17. We know this little part here is 8. So we can use Pythagorean theorem to find the length of part of this chord. Half of this chord, actually. So I'm going to take 17 squared. I'm going to subtract 8 squared. Whoa. That's rough. I am going to end up with 225, I believe. When I take the square root of that, then I get 15. And remember, 15 is just half of it. So my answer for the whole NP is going to be 30. I just need to double it. One last one here, and this is done the same way. We have a right angle here telling us that this part and this part are congruent, and I have a whole radius of 20 and a part here of 10. So if my radius is 20 and this side is 10, I'm going to find this length here, this other leg of the right triangle, by taking 20 squared minus 10 squared, which is 300. And then I'll take the square root of that, which is like 17.3 or something, I think. And then I just need to multiply it by 2 because that 17.3 is just part of, just half of the full QR that we need to find. So our total answer would be 34.6. Okay, let me know if you have any questions on this lesson.